Hello and welcome to another one of D's ADD videos. Today we're going to look at the difference between row echelon versus reduced row echelon. These two terms come up when we're using matrices to solve the system of equations. And there are two primary ways in which we're going to use these matrices to solve the system of equations. One of them is called Gauss-Jordan. And in the Gauss-Jordan method, what you'll be doing is you'll be solving your system of equations until you get to the reduced row echelon form. And that form is basically when you have the identity matrix to the left of your augmented line, as if you're doing the dashed line that I recommended, and then your solutions to your system of equations will appear to the right. So if you were interpreting this would tell you that x1 is equal to 1, x2 is equal to negative 1, and x3 is equal to 2. Alright? So this was the reduced row echelon form, and the main thing there was that the leading ones had zeros above and below. Alright, and we always got to have the leading ones incrementing to the right there diagonally. You might have one to where it skips one. That just means that you're going to have a variable that's a parameter. We'll deal with that later. The other way of solving is Gaussian elimination. My marker is acting up for some reason. There we go, welcome back. And in Gaussian, that's a U right there in case you can't read that. Erase that. Much better. In Gaussian elimination, we get to row echelon form. And in row echelon form, we have numbers above the leading ones, but zeros below. So in this case, if you were to do your row operations, this is what you should get. And again, there will be a video for both Gaussian and Gauss-Jordan you can look at. But this will allow you to do back substitution. This is your row echelon form. Again, zeros below, numbers can be above. And how this works is you'll be back substituting. We know x3 equals 2, and the same logic we had over here. But then we would use the columns to solve for x2. So here we have a 1, right, in the second column. So that would read like this. 1 times x2, and then there's the negative 1 in the third column. So it would be minus x3, and then that's equal to negative 1. But we know what x3 is, so we can plug in. I know I'm doing a little Gaussian video side note, but if I add 2 here, I get 1 there. I just wanted to show you that you also get the same answer if you did it this way. So in this case, x3 was 2 again, so 2 times 2 is plus 4. Subtract over, you get x1 equals negative 1, which those are the same solutions that I got if I were to do it the Gauss-Jordan way, as they should be, because they're the same system of equations, just solved 2 different ways. Okay? So I hope that's clarified things. on the difference between row echelon and reduced row echelon, check out the example videos on Gauss-Jordan elimination and Gaussian elimination to further clarify any doubts you might have. Thank you and have a nice day.